So we're going to start looking at unit circle trig. We're not going to get through it all today. We'll do some of it today, and then we'll do more unit circle trig next academic week. All right, so first of all, what is unit circle trig? Let's start with something like that. Okay, so start with a circle. Okay, you draw a set of axes through it. And the idea of a unit circle is that it's a certain size. Okay, we talked about it earlier. What's the size of a unit circle?
1.
Yep, what's 1?
The diameter.
No, 1 is the radius.
1 is the radius, yes. So we're going to be looking at how to do trig on a circle with a radius of 1. Once you know how to do it on a radius of 1, you can do it on any radius. It's just 1 is the easiest. The numbers are easier to do in your head. Okay, so the idea of unit circle trig is that you can take a point, you can put a point somewhere on the circumference of the circle, and that point has a coordinate. The goal in unit circle trig is to find that coordinate. Okay? So in this case, it would be a negative x value and a positive y value. That's the whole goal of unit circle trig. Find the coordinate for an angle. So let's say you did, let's do 4 that are easier than that one. Let's do 90. Where's 90 degrees on that circle? Yep.
Would it be like where the y intersects with the circle?
Yeah, so 90 degrees is when you rotate counterclockwise 90 degrees. Right there. And let's see if we can figure out the coordinate for that. It's a unit circle, so we know the radius is 1. So to get from the origin to the edge, going straight up, what do you think the coordinate for 90 degrees would be?
0.
0, 1. Yep. That is always the coordinate for 90 degrees on a unit circle. 0, 1. Always. So that's 90. Let's do 180. So 180 is right there. What do you think the coordinate is for a 180 degree angle on the unit circle?
Negative 1, 0.
Negative 1, 0. What's that angle when you go 3/4 of the way around the circle? That's
270.
270. And what do you think the coordinate is for 270? Yeah.
0, negative 1.
So 0, negative 1. And that point, well, it could either be 0 degrees or 360, depends if you visualize going around more than once. 0, which is the same as 360. And what's the coordinate for that? 1, 0. Okay, so those coordinates of the 4 what we call quadrantal angles. They are the angles that land on the axes, and the axes separate your plane into quadrants. And those coordinates never change. Okay, they are always 1, 0, 0, 1, negative 1, 0, 0, negative 1. So any question on finding coordinates for those 4? Yeah?
I'm sorry. So even if it's going like 1,000 degrees, the end coordinate would still be like if it's a multiple, like you said, you would still put it as the same degree. Like for example, if it was like 720 degrees, you would still put it at 1, 0, even though like when you draw it, when it asks you to draw like positive or negative degrees, you need to do the whole spiral thing where it goes more and more out. So technically, if you had like a whole bunch of rotations, it would be a bigger circle. You would still coordinate that as exact same coordinate.
Yeah. Yep.
The only reason I asked is because like visually it looks bigger the more rotations you get.
So when you rotate more than once, all you're doing is this. Okay, the size of the circle is not changing. You're just going around. So if I just went around, I don't know how many times, if I went around 4 times, well, that would be 360 times 4. but it's still the same spot as 360 or 0. So when we have angles that are bigger than 360, what we're going to want to do is make them smaller. We're going to want to find an angle that's coterminal and less than 360. How do you find an angle that's coterminal? Like if we had a negative angle, we'd want to fix that. Or if we have an angle that's too big, we also want to fix that. Yeah?
Add or subtract 360 degrees.
Right. That's going to make it easier to think about. So rather than thinking about a 2,000 degree angle, we're going to subtract 360, maybe 4 or 5 times, and figure out where it would be between 0 and 360. That's always the goal. Now, those 4 coordinates, 0, 90, 180, 270, those are easy to find, and they're very quick to identify. They all have a 0 in either the x or the y spot. Eventually, what we want to be able to look at is, how do you get the coordinate for a 45, a 30, and a 60? And we're going to find the 45, the 30, and the 60 in every quadrant. But you'll notice if I put those 3 points, that's how they look. Do they look evenly spaced between the 0 and the 90? Like, is the gap the same between all of them?
No.
No. That's because we're missing the 15s. To make them equally spaced, you'd need to figure out the 15 and the 75. We don't do the 15 and 75 for like a whole nother chapter. Okay, that's different. But we are going to look at the 30, the 45, and the 60, and we're going to do that in each quadrant. So we'll find like the 45 down there, 30, and the 60. And we'll save the 15s for another time. So I think these coordinates. So let's just start basically from that red line down. So once you find that coordinate, okay, the coordinate has an x value and it has a y value. Those x and y values are what are going to allow us to find the 6 trig functions of an angle. So what we're really doing is we're going to do a problem like the sine of 90 degrees. But to figure out what the sine of 90 degrees is, first thing you need is the location for 90 degrees. The x value is 0, and the y value is 1. That was the coordinate. Once you know the coordinate, I'm going to give you a formula that you plug the coordinate into, and that's going to tell you the sine. Right, so I'm going to define 6 trig functions in a minute. But if you can't figure out the location of the angle that they want you to work with, you can't do unit circle trig. You have to find a coordinate. That's the whole thing. All right, so I just said one of the trig functions, sine. There are 6 of them. 6 basic ones. Does anyone know some of the other ones besides sine? Yeah?
There's cos or COS.
What? What? Cosine. So sine, cosine, yeah. Tangent. Those are the 3 that you'll see buttons for on the calculator. And then there's 3 other ones. Yeah?
Cotangent.
Cotangent, yeah.
Secant.
Secant and
Cosecant.
cosecant. Yep. But we'll talk about the connection between the first 3 that you guys said and then the last 3. There's a connection.
And there's like the inverse.
There's also inverse trig. Yeah, it has like a -1 above it. We're not going to talk about those today.
Sure.
But yep, there's inverse trig functions. And there's other trig functions that you can talk about too. Yeah. All right. So we're going to start with the definition of sine, cosine, and tangent. First of all, every trig function has a 3-letter abbreviation. For most trig functions, it's just the first 3 letters. So sin, cos, tan. And when you use a trig function, what you plug into it is an angle. Okay, that's how a trig function works. So like if you write cosine, and then in parentheses you put what you're taking the cosine of. Right? So if I did this, There's no multiplication there. The parentheses just mean this is the thing that you're plugging into the cosine function. It's kind of like if I do this. That doesn't mean square root times 9. It just means this is the thing I'm plugging into the square root formula. Okay. Well, this is the thing I'm plugging into the cosine formula. Right? And that's called your argument. Just like in a log. Actually, yeah, that's perfect. When you do log 24. It's not log times 24. This is the number that you are taking the log of. Okay, same thing.
For the argument, can you use radians or no?
You can use radians or degrees. It kind of depends on the problem. The thing is, whatever you plug in, it has to be an angle. Like, you'd never take the sine of 4 centimeters. That doesn't make sense at all. That's like me asking you how long it took you to do your homework, and you said $5. That doesn't make sense. So whatever you plug into a trig function, it has to be an angle. And when we start to use the calculator, we have to make sure that if we want to use radians, the calculator is in radians. If we want to do degrees, we have to make sure it's in degrees. So when you press mode, there's fourth option down. It says radians and it says degrees. If we're doing a problem that's in degrees, okay, we just highlight degrees. And then hit enter. If you're doing a problem in radians, you can put it back in radians. It'll always tell you what mode you're in when you're at the main screen. If you just look at the top, it's the last one. It says degree. So I know that I'm in degrees. Okay. If you have a calculator that's a little different and it doesn't tell you what mode you're in, then you're going to have to check it before you type something in. However, you need to check it on your calculator. All right, so what's the definition of sine? Well, once you know the coordinate for an angle, the definition of the sine is the y value. The definition of cosine, that's the x value of your coordinate. And the tangent, you divide the y value divided by the x value. So we're going to do some more, but let's just see if we can figure this one out. If I wanted to know the sine of 90 degrees, what's the formula for sine? Yeah, it's the y value. And remind me, what's the coordinate for 90 degrees? Picture it on the circle.
0.
0, 1. What's the y value there?
1.
1. So if you type in the sine of 90 degrees, and you hit enter, you get 1. Sine is the y value. Now, cosine is the x. So for 90 degrees, what's the x value in the coordinate for 90 degrees? Yep. The x value is 0. So that's why the cosine of 90 is 0. Now the tangent is when you take the y value and you divide by the x value. So what's the y value divided by the x value? Yeah?
It would be undefined. Because
Undefined.
You can't divide by 0.
Yep. So the tangent of 90 is undefined. You can't do that.
Is this only applied to unit circle, like cosine and sine and tangent, or no?
These formulas, yes. These formulas apply specifically to use the numbers at the top. These formulas apply specifically to a unit circle. If you were doing them on a bigger circle, we could tweak the formula to make it work. But this is not for a generic circle, it's specifically for a unit circle. Yeah. You can use any size circle to do trig. It doesn't matter the size circle you use. It's just if we use a unit circle, the formulas are the simplest. Okay. Any question on those three? Let's look at the next three. So we've got the cosecant, the secant, and the cotangent. So I said the abbreviation usually uses the first three letters. Well, it can't do that for cosecant. because we've already used those three letters. So they use the syllables. Cosecant, sinus. And let me show you what the first one is, and then the rest of them, I think you'll be able to get based on the first one. So there's a connection between sine and cosecant. If you look at what the cosecant is, and then you look at what the sine is, what's the name for what we did? There's a name for what this is compared to what that is. This is the of that. Yeah, it's the reciprocal. So sine and cosecant are what we call reciprocal functions. You flip one to get the other. I've paired them up like this because these are all reciprocals if you read it horizontally. Cosine is the reciprocal of secant. So what do you think the formula for secant is? Yeah.
1 over x.
It's 1 over x. Yep. And the formula for cotangent? Yeah.
X over y.
It's going to be x over y. So those are the 6 trig functions on a unit circle. Now, you don't really need to know this, but these two actually stay the same on any size circle. If you did a circle with a radius of 20, you could still use those two formulas. But you couldn't use these. Right. We might talk about that later on, but not right now.
Why would you use the reciprocal? Like in which case would you use reciprocal?
When would you use a reciprocal? If I was doing something on a calculator, I wouldn't. Because the calculator doesn't have the 3 buttons on the right. All right. What you would want to do is, if you were solving a problem that had one of the reciprocals in it, you would want to change it to one that doesn't. So like, let's say you were trying to do, it's kind of hard for me to explain because we don't know a lot of trivia. Let's say you had like the secant of, I don't know, x equals, let's say, 3. And you want to solve that equation. Well, secant is a function, right? Like square root or log. The only way you can get rid of secant is to use what's called the inverse secant. That will cancel it out. The problem is you don't have an inverse secant button on here. So we can't solve that using the calculator. So what we'd want to do if we say, okay, well, if the secant is 3, then that would mean the cosine is what? Yeah? 1/3. Now that I can solve on the calculator and get rid of cosine because there is an inverse cosine button right there. That -1 is the symbol for inverse cosine. So the point is you wouldn't really want to use one of the ones on the right. You'd want to change it to one of the ones on the left. But you need to know which one it would change to. Okay, that's a ways away. That's a real ways away. But that's the idea. Yep.
For sine, cosine, tangent, all that, for the unit circle and the triangle thing, it's kind of unrelated, but like I heard like calculus is like measuring objects or something, or basically figure out dimensions measuring objects. So do those allow you to find like the area of imaginary objects kind of?
Not really sure about that idea of imaginary objects. That's not really,
Calculus?
no.
What do you think is like calculus is like main?
Well, without getting like into it too crazy, one simple thing is calculus allows you to find the point anywhere on that curve. The
Okay.
slope.
So like kind of interpreting data. So if I wanted to find the exact point on like that data, like I could use the sine, cosine, and tangent to find an exact path, just like visually. Well, an exact point, kind of like visually, if I knew the angles.
Maybe. I'm not sure.
How would you use sine, cosine, and tangent on that? That's what I'm asking.
Oh, that would I don't think that would relate to trig at all. Like, that's just when you would ask like what's calculus. That's one example of calculus, finding the slope on a curve. Another example in calculus is if you had something like this, finding the area of this shape.
Yeah.
That's another example. Again, does that connect to trig? This one could. It depends. Depends what the formula was for that. So when you do derivatives and integrals in calculus, you will work with trig functions some of the time.
And those derivatives will be for, like, is there a physical manifestation of derivatives, or is it just like a mental thing, like numbers and statistics?
No, there's applications which you'll learn all about next year.
All right.
Yeah.
The reason why I'm asking is because, like, for when I thought like calculus was the measuring objects, like that makes sense. Because for the measuring objects or the presented objects, you only know certain things about them, and so you can use those certain things to find the rest about them. That's why I asked.
Yes. Maybe.
Sorry.
I'm not sure. I do know my calculus is about at this point 22 years old, so it's a little rusty. But I mean, I still remember some things. Mr. Bad would be better to talk to about like applications for it. Those are the only two that are real basic. But there's all kinds of applications to different things. So you'll do a lot with trig next year. And that's where most people get stuck because they don't remember some of the trig stuff. And he doesn't really go back and explain that in detail. Like, you just kind of need to know the trig. That's like background to actually do the calculus. Algebra in general is the background for everything in calculus.
Yeah.
So like if you have a quadratic equation, he'll just expect you can solve that. He's not going to go through like how to do it. That might be one small step out of like 5 steps in a calculus problem. Quadratic formula.
Thank you. It just came to mind because of the sine cosine tangent thing.
So the angles I mentioned earlier, the 0, 90, 180, 270, those are your quadrantal angles because they are on the axes and they divide the plane into quadrants. So if you see that term, now you know what the quadrantal angles are. So how do we figure out the sine, the cosine, the secant, whatever they want to know for an angle? Well, the first thing is the angle itself isn't useful. What you really need to know is the location of the angle. What is the coordinate of the angle on the circle? And as I said before, you can use any size circle you want. But if you don't want to use a unit circle, then we have to adjust all these formulas to be a little bit more generic. Okay? The formulas I'm giving you right here are specific for a unit circle. It's not a big adjustment to fix them so they work on any circle. But you just kind of do one thing at a time. Okay, so step 1, find the coordinate for the angle that they're having you work with. Sometimes the coordinate will be given to you. If the coordinate's given to you, then step 1's already done. Here's a problem that we're going to do in a minute where they're giving you the coordinate. Hopefully you recognize. You don't have to recognize what angle that is, but hopefully you do. Here's another one that you probably wouldn't recognize. We haven't talked about that coordinate yet. Well, this coordinate is going to represent an angle. You don't need to know what angle it represents. All you need to know is that's an x value, that's a y value, and you're going to fill those two numbers into those 6 formulas. Some of you that have maybe worked with angles before, you might know what angle that is. Anybody know what angle that is?
It has to do with the 30, 60, 90 triangle, right?
It does. It has to do with a 30, 60, 90 right triangle. And that one is the short side is the bottom, the tall side is the height. That's a 60-degree angle. That's the coordinate for it. If you don't know how to find that coordinate yet, that's okay. That's not what you have to worry about today. Okay, but step 1, if I have you find a coordinate, it's going to be an easy one to find. It's either going to be the 0, 90, 180, or 270. Okay, just the 4 that we went over. Now step 2 is once you find the coordinate, fill those into the formula. Which formula? Well, whatever they want to know. Sine, cosine, secant, cotangent. We'll do all 6. Okay, I wouldn't ask you to do all 6 in the same problem on the test. I'm just going to ask you for 1 per problem. But for today, we'll practice all of them. Okay, so any questions on the 2 steps to do unit circle trig? Find the coordinate, plug it in. Now, our rules for fractions always apply here. You can reduce a fraction, go ahead. And what do you never want to leave in the bottom of a fraction? I mean, I know you can't divide by 0, but that's not what I'm asking. What don't we usually leave in the bottom? Yeah, we don't leave square roots in the bottom. So if you have a problem and it has a square root as part of the coordinate, at some point you're going to end up flipping that number. You're going to have to do a reciprocal. And we have to fix it if the square root ends up in the bottom. Okay. So we're going to find the 6 trig functions represented by that coordinate. Now, hopefully you do know that angle. What is the angle represented by 0, 1?
90 degrees.
It is 90 degrees, but you don't have to know that for this problem. So we're going to find the sine of the angle represented by that coordinate. And we'll do the cosine and the tangent. What's the name of the trig function you get when you flip the sine? Cosecant. Yeah. How about when you flip the cosine? That's what? Secant. And when you flip the tangent? Let's see. Cotangent. Okay, so let's start with sine. What's the definition to find the sine using a formula on the unit circle? Sine is the
X, the X coordinate. No, Y coordinate.
y coordinate. Sine is the y. And what's the y in our coordinate? Come. So the sine of the angle represented by that coordinate is 1. What's the definition for cosine? It's the x, and in this case, 0. Yep. How about the formula for the tangent? Yeah. Y divided by x. What do you get if you divide y by x? Undefined. Now, once you get the 3 on the left, the 3 on the right are quick. The 3 on the right are all the what of the 3 on the left? They're just the reciprocal. So you don't even need to think about a formula this time. Just take the answer you got before and flip it. So what do you get when you flip 1? 1. How about when you flip 0?
Undefined.
Undefined. And if you're not sure why, well, here's 0. If you flip it, now you have that. So when you flip 0, you get undefined. How about when you flip undefined? Yeah.
It's going to become 0.
It's going to be 0. So that would be 6 separate questions. So any question on finding the 6 trig functions for that point? The only ones that can have undefined values are the quadrantal angles. And that's because there's a 0 in the coordinate. If you don't have a 0 in the coordinate, you'll never get an undefined. You can't. If this is a number and that's a number, you'll always get values for all 6. Like in this one. So we talked about it a little bit. But does this look like the coordinate for a quadrantal angle?
No.
No, it's not. Quadrantal angle would be a 0 and a 1, or a negative 1. Most coordinates on the unit circle have a square root in them. So now, what's the angle that represents? Who cares? The thing that you need is the location. That's what helps you do unit circle trig. Okay, let's start with the sine. What's the sine of the angle that's represented by this coordinate? Yep.
Square root of 3 over 2.
It's the square root of 3 over 2. Now, just to make the connection, let me show you something. What angle did we say that was earlier?
60.
It is. That is the coordinate for a 60-degree angle. So watch what happens if you take the sine of 60. It doesn't say square root 3 over 2. But if you type in square root 3 and divide by 2, that is what it is. Right? So we also want to start to get familiar with these decimals. Okay? We would always write the answer as square root 3 over 2. Okay? Not 0.866. Any question on that idea? So I'm just kind of showing you the connection between doing it on the unit circle and doing it on the calculator.
Function-wise, would it have showed you the square root of 3 over 2 if you did the math function of turning the number into the fraction? Would it have shown you the square root of 3 over 2?
No.
Is it not able to show square roots in the fractions?
Right. Can only show you
Proper.
rational numbers.
Okay.
That's technically not a rational number because to be rational, the numerator and denominator have to be integers. That's not an integer. So the calculator can't do that. No. Okay, let's do the cosine. Okay, what's the formula for cosine again? Yep. X. What's my x in this case? 1/2. So this time, the calculator will give you a nice answer. If you type in the cosine of the angle represented by that coordinate, and again, if you don't know that it's 60, that's okay. You don't need to for today, but you get 0.5. Okay. And now let's do the tangent. Formula for tangent is y over x. So a lot of times what I do visually is I just go like this. Just imagine putting a fraction line there. That's y. That's x. So we're going to divide those two fractions. So 3 over 2 divided by 1/2. And we need to simplify that as much as we can. Okay, how do you divide two fractions?
We'd be multiplying them. The bottom one would be the reciprocal.
Yeah. So you keep the top the same, change to multiplication, and flip the one that's in the bottom. So what's the first thing that happens when you multiply those together? Yeah, what cancels? The 2's. And I would have done that just by looking at these. If you divide two fractions with the same denominator, you can just cross the denominators out. And all you're left with is square root 3 in the top and 1 in the bottom. And there you go. So that's your tangent. Okay. What's the trig function when we flip the sign? Yep.
So you need to divide by square root of 3 to multiply them both.
So yeah, we're gonna have to fix it. But what's the name? Like, what letters am I gonna put here? Cosecant. Yeah. And as Mia said, you are gonna flip that. Okay. Once you get the 3 on the left, don't even think about formulas anymore. Just flip it. 2 over the square root of 3. But when you fix that, how does it look once you rationalize it? We can't leave it as 2 over the square root of 3. Yep. Yep, you multiply by square root of 3 over square root of 3, and what will you get? 2 square root of 3 over 3. Perfect. Okay, how about the secant? What's the secant of the angle represented by the coordinate we were given?
2.
2. Just take the cosine and flip it. So there's our secant. And the last one, what's the name of the function when you flip tangent?
Cotangent.
Cotangent? Now, we don't have a fraction to flip. Make it a fraction. Okay, so your first step, what do you get when you flip the tangent?
You get 1 over square root of 3.
You get 1 over the square root of 3. And when you fix it, What's your final answer going to be? Jacob?
Square root of 3.
Square root of 3 over 3. So you notice we don't use decimals in any of this. Okay, you never use decimals. I mean, I guess you could write the cosine as 0.5. That's okay. That's exact. But we don't want to write like 0.866, 1.73. We don't want to use decimals. We're dealing with angles that are not multiples of 15. Like if I said, what's the cosine of 12.4? Then we'll use a decimal. Okay. But unit circle, the point is we're always sticking with angles that are multiples of 30 or 45. And 15s eventually, but not yet. Good. Any questions on that? Okay, so both of those, they gave you the coordinate. Now let's try this one. Find the 6 trig functions of 90. Okay, what's different about this question than the last one? Yeah?
They don't give you the coordinate.
They don't give you the coordinate. Well, that's the whole key to doing unit circle trig. You need the location. So now you have to figure that out first. Right. So what's the coordinate for 90 degrees?
0, 1.
0, 1. And that is the problem we just did. So it's now all the same answers as example 1a. Only extra step was finding the coordinate first. So now that we did example 1a, are there any other questions on it? Because you'd have to do this again, exactly the same thing. Okay, so those are your answers. Okay, 6 trig functions of 270. By the way, it's not always 6. They may just ask for 1 or 2. So only do what they ask for. Okay, but they are asking for all 6 here. Okay, think about the circle. Where's 270 on the circle? Try to visualize it. Yep. Yep.
Would it be negative? Oh, so 0, negative 1.
0, negative 1. Yep. And now we can go through all our functions. Okay. What's the sine of 270? Yep.
Negative 1.
Negative 1. What's the cosine?
0.
0. What's the tangent?
Undefined.
Undefined. Okay. How about somebody else? What's the cosecant? Yeah. Yeah. Negative 1 is one of 2 numbers you can flip and it stays the same. Negative 1 you flip, still stays negative 1. How about the secant of 270? Yep. That's undefined. And what about the cotangent of 270?
0.
0.
Whenever there's an undefined term, you're negative 1 and to the power of 1, it'll be 0 the long way.
And just to be clear about all the things circled in red, there's no label on that. It's not like 0 radians or 0 degrees. The radians or degrees is what's plugged in right here. The answer that you get on the other side is just a number. There is no label on that number. And if you kind of want to understand why there's no label, you can think about right triangle trig. When we do this in right triangle trig, to find these trig functions, you have to divide 2 sides in a triangle. Well, if one side was like 3 centimeters and the other side was 5 centimeters,
The centimeters would cancel out.
the centimeters cancels out. So if you think about it that way, that's why there is no label on any of these answers, because they really represent dividing 2 sides in a triangle. So the length unit is gone. If it doesn't make sense, that's okay. Just think there's no labels on it. That's what you need to know.
Can you take, like, if you give us a problem, you say find like the sine or cosine or whatever, if it's in radians, do we have to flip it to degrees first?
That's up to you. So if they give you something that's in radians, like find the 6 trig functions of pi radians, I don't care how you want to think about pi. All I care about is, can you tell me the 6 trig functions of it? So the first thing that you would need to know about pi is to do any unit circle trig, you really need to know the what.
What do you mean? You need to know it? Because I know pi was like 180.
So what do you need to know to do unit circle trig? Bottom line, you need the what?
The location of the quadrant. Whatever word is from the angles like 90, 180.
So in one word, tell me what you need. You need the
Location.
yes. You need the location. You need the coordinate. So if you can figure out the coordinate of pi without changing it to degrees, great. If you need to change it to degrees, that's okay. It's going to take you an extra 10 seconds, but it's not a big deal. Where is pi on the unit circle?
-1, 0.
So pi is over here, and that's halfway around because 2 pi is a full revolution, so 1 pi is halfway. Okay. Now we can do our 6 trig functions. Okay. What's the sign of pi? Yeah?
0.
0. How about the cosine of pi?
-1.
-1. And the tangent of pi?
0.
0.
Oh, wait, no.
Tangent is 0 divided by -1. So that's okay.
So that would make cosecant undefined.
That makes the cosecant undefined. How about the secant?
0.
1 over -1, so just -1.
Right, when you flip -1, remember it's the reciprocal of this. So when you flip -1, it stays -1. How about the cotangent?
It would be undefined.
Yep.
So for this type 1, we have 2 undefineds.
Yes. Yep. Okay, I'm pretty sure whenever there is a quadrantal angle, you will always end up with 2. You'll always end up with 2 that are undefined, 2 that are 0, and then it could be 1s or -1s, depends on the problem. Excuse me. Thank you. Let's look at this one. 7 pi over 2. Some people, they might not be as familiar with that one. So if you have to, you could change it to degrees first.
That would be
How would you, let's kind of go through it just step by step. How would you change 7 pi over 2 to degrees? Yeah.
180 over pi. But if you're just doing based off memory, pi over 2 you can remember is 90 degrees, and then you can multiply that by 7 radians, but that's probably more simpler. Is there a way to do this faster if you know that pi over 2 is 90 degrees?
Yeah, in my head I think 90 times 7. So it is going to end up being 630 degrees.
When you need to multiply it by 7 radians, because like 90 is 9 degrees and 7 radians, you need to change the 7 radians.
No.
Or you can just multiply it?
Yeah.
This is the conversion from radians to the.
So if we do it the way I showed you without using a shortcut, it's multiply by 180, divide by pi. Pi's cancel. And then 2 goes into 180 how many times? How many times does 2 go into 180? Yep. 90. And now you're left with 7 times 90, which is how much?
630.
630. Now, I still don't like that angle, really. Because why do you think I don't like that angle? Yeah?
Because you have to do a whole revolution.
Right, I'm going around more than once. I don't want to go around more than once. It's too complicated to think about. So how can I make it so that I can find an angle that is coterminal with that? Yeah?
Well, I mean, you could subtract 360
Yeah.
until you get the base, which is 270.
So it's the same as 270. And 270 was example, well, actually, let's write the coordinate first. What's the coordinate for 270?
0, -1.
0, -1. And I think we did that right here. So that's example 3. So a lot of times problems might be written a different way, but once you simplify it, it's actually the same as another problem. Yes?
My question is, instead of doing all that math out, I mean, it's not that much, but anyway, couldn't you just put your calculator into radians and then do cosine and sine of 7 pi over 2 to get your x and your y? And then just do that, and then it'll do it in a calculator, and then the answers will be your x and your y values, and then you don't have to find the location.
So what's going to happen is when we do ones that are not quadrantal angles, remember it's going to give you like decimals, like 0.866. And I'm not going to want any decimals. I'm going to want exact answers.
Okay.
So, and the other thing I may ask you, like on the test, is, let's say I gave you one like this. I'll say, give me the coordinate for -90, which the calculator won't give you the coordinate. So I'll say, what's the location of -90? And then I'll say, give me one of these 6.
Okay, I mean just for like if it's in radians, not if it's in degrees, but if it's in radians.
So radian, same thing. If I give you one like, find the 6 trig functions of 7 pi over 2. First thing I'm going to say is, what's the location of 7 pi over 2? So you're going to have to tell me that as a coordinate. And then I'm going to ask you for one of these 6. So you still need to know how to find the location of this point. And the calculator won't be able to tell you if it's like 0, -1. Like you can't get this information from the calculator. Does that make sense?
Yeah, I guess.
So the calculator can't give you the coordinate for 7 pi over 2. And I'm going to ask you for that.
Okay. Because like if you put that in for, if sine is y, right? Sine of theta is y.
Mm-hmm.
So could you just put that into for sine and then get your y value?
So
Coordinate.
what if you had this though?
The map anyways.
Cosine of 300. Well, that was a bad one. Let me do a different one. Cosine of 300. Okay, what's your y value exactly now? Or x value?
Okay, because you don't get the.
I don't want 0.866, no. I want to know the exact answer.
Okay.
And that one you may say, oh, I'll just memorize that. 0.866 is -√3 over 2. Okay, well, how about if I do cosine of 285? Now that's a multiple of 15. Good luck figuring out what that is as a fraction if you don't know how to do it.
So you're just better off. Okay, so
Yeah.
mostly for the fraction answers.
Right, because you're going to have to write the coordinate. Yeah.
So it works in some cases, but not all cases.
Yeah, it might work in cases where you get a nice answer, but not when you're going to get decimals.
Okay.
And this doesn't give you a hint. This has square roots of 4s in it, and square roots of 2s and 6s, I think. Square root 2, square root 6, and denominator of like a 4. So you'd never figure that out without knowing how to do the coordinate. And I'm not going to really teach you how to do that one today. But that's where we're going. So that's why I want you to know how to do coordinates.
You already said if we have a square root in the fraction, it's not going to give us that. But if we do put it in, could we use that fraction? Could we figure out from there what the square roots are? Or was it just going to give us like an error? Like if we had square root of 3 over 2 as like the coordinate thing, and you plugged it in, and it gave you like a fraction of like a 10 million, or like 10,000 over 3,000 or whatever.
Well, it won't give you a fraction. It won't. It's not going to do that.
It's just going to do an error?
No. It's just going to give you back the same thing you started with.
Oh. Okay.
You can't convert trig decimals like that to fractions because the calculator can only do rational fractions, and that's not a rational fraction
Okay.
because it has an irrational number in the numerator.
So if we wanted to find the coordinate for -90, is it the same as 270?
-90 is exactly the same as 270. Yes. Yep. It's the same thing.
Can you put the negative into the cosine, like into these functions?
You can plug in a negative, yeah. Yeah. The domain of sine and cosine is all real numbers. You can plug in any positive, negative fraction, decimal, or 0. Now, when we get to like tangent, secant, and cosecant, that's not true. Because there are values that are undefined.
Yeah.
You cannot plug pi into the cosecant function. Okay, it doesn't work. Okay, any, well, actually, I think somebody just asked about -90. What angle is -90 the same as? it's the same as 270. So if you can find an angle that's coterminal with it, especially one that you've already done, then there's not much you have to do. So this is the same as example 3. This is the third time I've asked the same question. Example 6, example 5, and example 3 are all the same answers. So any question on how you do the trig functions from here? Just get your coordinate and just fill it in. Okay. So any questions on anything we covered today? Okay, so I'm going to pause the video. I still got about 13 minutes. I'll put in the topics that are on the test. Once I write them down, if you do have any questions, you can ask me and I'll try to explain the topic. Okay, so first, let's write this down. So the homework, so you just have to pay attention to what I'm writing here. I want you to do 1, 5, and 8 in the book, okay, the way they write the problems. And then I also want you to find the 6 trig functions of 1, 5, and 8, and the 6 trig functions of 3 pi over 2, 2 pi, and square root 2 over 2. So you're doing 1, 5, and 8 in the book. You're finding the 6 trig functions of 1, 5, and 8 after. And then I want you to find the 6 trig functions of these. I think 1, 5, and 8 are finding a coordinate. So it's going to lead you to doing what I want you to do. Let me...
Not about how you think, because I can any of you.
It's fine.
Just